Our last new piece of information for today. In a circle or congruent circles, so I could have two circles that are congruent, two chords are congruent if and only if they're equidistant from the center. So if they're the same distance from the center, then those two chords are congruent. So if XL is congruent to LY, then FG is congruent to JH, the whole length. Not just a portion, the whole length. Okay, so if those both are the same distance apart, then they're congruent. All right, so if in circle Q, CD, which is a chord, is congruent to chord CB, then we're saying GQ, which is this length right here, x plus 5, and this one is 3x minus 6. If CD is congruent to CB, then GQ has to be congruent to QE. So those two segments also have to be congruent. So GQ has to be congruent to EQ. So we can say x plus 5 is equal to 3x minus 6. You get 11 equals 2x. So x is equal to 11 over 2, which is 5.5. So again, lots of congruent things that need to be set equal to each other, that kind of stuff, guys. Last example for the day. In circle R, TS is 21, and UV is 3x. Well, because I can see that WR has a measure of 6 and RZ has a measure of 6, that these two pieces are congruent. Therefore, these two are congruent, so I can say that ST is congruent to UV. So 21 is equal to 3x, therefore x is equal to 7.